Hello, in this video I'm going to show you how to build a simple lab intended to help you to learn and test how a firewall works based on OPNSense Firewall and some essential networking tools like Nmap and Wireshark. The lab is built using VirtualBox, however it could be built using any other virtualization platform like VMware or Hyper-V. The video covers how to download OPNSense Firewall software, how to install it and how to perform initial configuration. It described the network architecture of the lab and connecting additional virtual machines which are needed to perform tests. Using this lab, you can test various concepts related to firewall operation, ranging from essential port forward or filtering and network address translation up to more advanced aspects like VPN, intrusion detection and prevention, monitoring and threat analysis. This diagram presents the components of the lab. A green rectangle present virtualized components of the lab when VirtualBox NAT provide the access to the outside world. The main component of the lab is OPNSense virtual machine connected to two separate networks. Network connected to the first interface represent WAN or external network. We are going to configure it using VirtualBox NAT network. Network connected to the second interface represent LAN or internal protected network. Inside LAN there is a virtual machine which hosts services like web server, which later can be published via the firewall to the outside world. In our case, it's going to be Ubuntu server with Nginx, Nmap and Wireshark or packet capture. The testing server, whose function is to simulate remote connection to the service shared via the firewall, is installed inside the WAN network. In this case, it is Kali Linux virtual machine. The testing server can be later connected to LAN network also. Please pause the video for the moment and review how the network is set up, including IP addressing. It is essential to understand how networking inside VirtualBox works, what different type of networks is available. If you are not familiar with it, this couple of articles could help. You can pause the video here and review them. Article by Simon Cotter is perfect starting point. There is one thing to notice. It explains NAT. However, please remember we are going to use NAT network and not just NAT as our wide area network. We have here as well description of host-only networking, which in the lab works as internal local area network. Another article is by Martin Smith. It's a perfect condensed summary of networking modes in VirtualBox. It's good to get a helicopter view of it. At the end of this article, we can find a couple of different case studies related to various implementation options. And obviously, another good source is VirtualBox documentation, VirtualBox manual. This is the entire chapter 6 about the networking, and particularly this point here, introduction to networking modes. It's explained them briefly, and it will provide us with a table which summarizes various different modes. And we could see what can connect to what. So, for example, if we want to have one virtual machine talking to another virtual machine, we cannot use just NAT. And if we want to have connectivity to the internet, host only do not provide connectivity to the outside world. And that's why we are using host only networking as our internal LAN, because that is blocking access to the outside world, and the access to the outside world will be provided by the firewall itself. So once we understand how lab is going to function, we can start building it. The first step would be to download OPNSense Firewall from OPNSense website. First, go to the download link on the top of the page. It opened main page. On the top of this page, you can see the button to make optional donation to the OPNSense project, which would support further development. It is something worth to consider. Scroll down and you can see download option. You can choose architecture, 32-bit or 64, in our case 64 bits. Then there is a selection of various different media option. Depends how we're going to install. We'll select DVD to get ISO. And once we have it, we'll go to choose the location. We'll be downloading from University of Kent, but you can choose another option. And once you hit a download button, it will start downloading itself. Now, in the meantime, you can notice on the bottom there's a hash value for the file. So once you download, you can verify that downloads happen without any errors. We have all of the components to start the installation of the lab. The first step is to prepare virtual networks. I'm starting with preparation of wide area network, which is in the front of the firewall, which means it is connected to the internet-facing interface of the firewall. For this purpose, I'm going to create a VirtualBox NAT network. Please note the IP address which I'm going to use. It's a private IP addresses range. To configure NAT network, I can use VirtualBox GUI. I'm going to Preferences. One of those icons is network. This is where I can configure NAT network. So there's the icon to add new NAT network. The new network has been added. I'm using the icon to edit properties. First, what I'm going to do, I will rename it so it will be easy for me to identify. So it's 10.0.100 network. And what I have to do, I have to adjust my network address. So this is exactly as I had in plan. So it's my 10.0.100 0x24 network, and this network is going to support DHCP. So it means hosts which are added to that network will have addresses assigned automatically from the range which is related to this segment. And at this stage, I can click OK. The network has been created. The next, I have to click this OK, and at the moment, VirtualBox has new NAT network configured. So what I've just done, I've created this NAT network which is connected to the internet-facing interface of Firewall. And now I'm going to create a VirtualBox host-only network, which is going to be used as my local area network. So to create host-only network, which will be used as my LAN, I'm using Host Network Manager. When here, I can use create icon, create new network. We can see that this is that has been created here. What I have to do, I have to adjust my IP addressing, so it will be exactly as on my diagram. So 172.16.101. This is the address of the newly created interface. Just click apply. Once again. Okay, we have the IP address created here. The next, what I have to do, I have to set up DHCP in this interface. So the IP address has been populated automatically according to my address. So I can click apply. DHCP is enabled. We can verify that all the addresses are as intended, and it has been configured at the moment. So once networks are in place, I can start building a virtual machine. So I select new virtual machine. I give it a name. Number 1, just in case if I would build more of them. I select this BSD, and this is OpenBSD 64-bit. I'm going to adjust amount of RAM, and will create a hard drive. It will be VDI, and I'm going to make it a little bit bigger. I may need it later, so I put 20 gigabytes, but it's dynamically allocated. In this case, I can stay dynamically allocated. So the machine has been created. There's a couple of configuration options what I have to do. So I'm just going to use settings option. And the first, I'm going to storage. There's empty DVD drive. So what I'm going to do, I'm going to select my OPNSense ISO. If you don't have OPNSense ISO on the list, you can click choose virtual optical disk file, and then select wherever in on the file system you had a DVD downloaded. I have this already in the list, so I'm selecting OPNSense ISO here, and click OK. There's one more adjustment what I have to do on the networks. So my first adapter is going to be connected to a NAT network, and this is going to be this one. That's the network what we have created. And the second adapter, I want to have it connected to host-only adapter, and that was the last one. So that's my internal LAN network. Once it is done, the machine is configured and it's ready to first boot and initial configuration. So everything is ready, and we can start OPNSense for the first time. So I'm going to click the start button, and the machine will start booting. Now, what's going to happen for the first time, because the installation media is connected, it's going to boot from the installation media and will be running in the live mode. So it will start. We can either continue running from the installation media, or we can do installation on the locally installed partition, the virtual drive. What I'm going to do, I will pause the booting process at the moment and restart once installed. So the firewall is started, and we are on the initial login screen. As we can see, we got a message here that OPNSense is running in live mode, so it is running from the ISO file. And what we could do, we could either log in as root, or we could log in as installer. If we log in as installer, we'll start installation on the locally attached disks, and this is what we are going to do. However, what's possible to do for the testing purposes, it's possible to start OPNSense in the live mode. We could do various different configuration. We could try something, and then it could be restarted and started again in the clean settings. So depends what we want to do. For the purpose of our lab, we are going to do installation, and that's what we'll do now. So I'm logging on as installer, and the default password for both root and installer is OPNSense, or lowercase. So it's exactly as the name of the firewall. So I'm logging on, and the installation process will begin later on. So I'm accepting the default settings. Here I can select the disk where I'm going to do the installation, and I have to wait for the moment until installation process will finish. In a moment I will be asked to enter a new password for root. Okay, so this is the moment where I have to enter the new password. The password is entered, accepted, and I'm going to reboot machine. Now, the one thing to remember, at the moment we still have installation media inserted. So what I have to do, I have to go to the machine settings, and I will have to remove the CD here. But in order to do it, machine has to be stopped. So I have a virtual machine started. This is a machine with default settings. Firewall did assign interfaces by default. What I can see that LAN interface, local area network, is EM0, and the WAN interface is EM1. I wanted this to be assigned differently. So what I'm going to do, I'm going to first log on to the firewall for the first time. So I'm logging on as root. Wrong password. Now I'm logged on, and I'm going to use the menu system here to change interface assignment. So the first thing is I select option 1 to assign interfaces. I don't want to configure VLANs at the moment. So what I want to do, first I want to assign wide area network interface, and wide area network, so the internet facing interface, I want to be EM0. And the second question is about LAN interface, so I'm going to assign this to be EM1. I'm not entering the optional names. So I can see that one wide area network is assigned to EM0, local area network is assigned to EM1. This is exactly what I want to have, because that was my plan on the diagram. So I'm choosing Y and waiting until configuration will finish. So I can see, yep, they are assigned exactly as I wanted. The only problem is that the LAN interface at the moment is assigned with static assignment. So when OPNSense start, LAN interface has fixed IP 192.168.1.1. We could connect to it, but what I want to do, I want to use internal DHCP. So I'm going to change this. So what I'm going to do, I will choose option 2, set interface IP addresses. So I'm going to change configuration of EM1 interface. So I'm selecting option 2. And I'm going to change LAN interface, so select option 1. And I'm choosing option 2, configure it via DHCP, IPv6, I don't want to have it, so I'm staying with IPv4. And it's asking me, do I want to configure interface via HTTP? This is lab situation. I can just configure in via HTTP. Normally we would stay with HTTPS. So what has happened? We can see that LAN interface is 172.16.103. So this is exactly from the as we have configured as per our diagram, and we'll be able to continue with the initial configuration in the moment. So what I'm going to do, I'm going to log on for the first time to the firewall. So this is the internal LAN interface. Just to remember, we are using host-only network, which means that host can connect to that subnet from outside. So I'm connecting from my host. The username is root, and I enter my password. And I'm connected to the firewall for the first time. Firewall offers us to use wizard. I'm not going to use this wizard. We'll do configuration manually. We just go through all of the options. Here on the left hand side with the menu. When I go to a lobby and a dashboard, I can see how the firewall is configured at the moment. So I can see we have two interfaces. We have LAN and WAN. We could see IP assignment. We could see the snapshot of the current usage, how much memory disk and CPU is used at the moment. And I'm able as well to restart or stop main services of the firewall. So we'll be using this interface for the configuration of the firewall going forward. So before we start using firewall, there's a couple of changes which we have to make because of the specific environment where the firewall is working at the moment. So please have in mind that a firewall usually the one interface, wide area network interface, would be facing internet. So the fact that we have a private address here is a little bit unusual, but this is our lab. And as a result, we have to make a couple of changes here. So the first change, what we have to do is on the one interface. So here in the menu, I will go to interfaces. I go to one interface. We can see that interface is enabled. And there are two options here. One is to block private networks. So basically what's going to happen, the firewall do not expect to have any private, any reserved networks in the front of itself. So all the packets which have source packet coming from the private network, so 10.192.172, they would be blocked. If we click here on this explanation, that's exactly what's going to tell us. So those network ranges wouldn't be able to communicate with our firewalls from the one interface. So what I'm going to do, I'm going to unclick this option. This is essential for lab to work. As well, some other reserved networks are blocked as well. So what I don't have to unclick it. I'm unclicking it because I don't need this this option here. So once this is unclicked, I have to click the save, and I have to do apply changes. And this process will have to be repeated every time when we make any changes on the firewall. So we always save. We can make a couple of different changes, and then when we hit apply changes button, all those changes would be applied at once. So that was first change what I had to do. There is something else here in the firewall configuration. When I go to settings and advanced, there is an option, disable reply to. This option could be used if we would have multiple one interface. I'm not going to explain this to dig into this option at the moment. I'm just saying that this option we have to disable for our LAN to work properly. Again, I'm going to save it, and this specific option is applied straight away. Once I save it, I don't have to do anything. So firewall settings advanced, and there is this option here, disable reply to on one rules. So that's done, and we will be able to start using firewall now. So as a reminder, we can have a look on the diagram, and we have installed OPNSense already. We connected to those two networks, front network which simulate the internet and the LAN network at the back. What we have to do, we have to add two virtual machines, one Kali, which will be probing our firewall, and Ubuntu, which will be hosting web server, which we are going to publish through the firewall. So the last part of configuration is to connect those virtual machines. I have those two of those virtual machines already prepared here in the VirtualBox. So the first one is the Kali Linux. All what's required is to install a virtual machine with Kali Linux. So you can please do it. Prepare a machine like that. So what I'm going to do, I go to settings of that machine, and under network I want to select that this is NAT network, and I have to select the NAT network which I've configured for our firewall lab. So once I click OK, this is connected in the right place. For my machine with Ubuntu, which will be behind firewall, the second machine is hosting a web server, and this web server will be published via firewall. So again, I'm going to settings, I go to network, and in this case I select host only adapter, and I'm going to connect it to this last network, because this is our LAN. At the moment the configuration exactly as per diagram is finished. So let's start using our firewall a little bit. Internally to the LAN network, we have connected the Ubuntu machine. If I check IP address of the machine, this is the IP address, 172.16.104, and on this machine I have two services working. I could actually try to run nmap just to scan this machine 172.16.194. So it did run the quick scan, and what has detected on 10,000 port, there's some service working, and on port 80 we have a service working. When I have a look here on port 10,000, we have actually default website, default Nginx website. It just says, yeah, port 10,000. And on port 80, we have different website which says port 80. They are two static websites. I've just configured them in the folder, so we will be able to connect to those services through the firewall and see if they are visible. And for the purpose of this lab, you can have on the Ubuntu behind firewall, you could have any other services working. So we saw that there's on the Ubuntu is SSH as well there. So that is another service we could host. You could install Apache or Nginx. You could have any other service, or you could use NCAT to simulate any other services and then try to connect. So this purely some sort of machine which is hosting services inside in LAN, and those services are going to be shared through the firewall. So it could be really anything. There's one more thing what we have to do here before we start configuring any firewall rules. What I did in this lab, I have installed Ubuntu. I've connected Ubuntu to host-only network, and host-only network is our LAN network. Host-only network is designed to be an isolated network. It shouldn't have any connection to the internet. So as a result, there is no gateway. There is no default gateway, and DHCP on VirtualBox is not providing default gateway. So if we have a look here, there is no default gateway. There's nothing which will route packets outside of that network. If I try to ping any IP outside, is obviously it doesn't work. And the reason why it doesn't work is because there's no default gateway. Not only this, we don't have name servers either. So what we have to do, we have to configure a static IP with a default gateway and with DNS servers. The way how it is done, this is Ubuntu 18.04. This version of Ubuntu uses so-called netplans. So what we have to do, we have to edit a netplan file. A netplan file is in etc netplan folder. They could be multiple different files. We have to figure out which one is valid file. On default installation, there will be just one. So what I would recommend is to familiarize yourself, is just to read a little bit about how the net plans and how the network is configured on Ubuntu. And now we could be using any other operating system, but we are using here 18.04, so we are making those change at the moment. So the command what I need to use, I'm using vim to edit a file, and I use sudo command because as a standard user I wouldn't be able to edit it. This is the configuration at the moment. So what we have here, there is just a configuration of DHCP. What I'm going to do, I will leave this DHCP configuration, but I'm going to add a static address to it. So I just got myself the configuration here. So let me copy it, and let me add that information to the file. So this is the syntax, what I'm going to use. So DHCP, I'm going to add a static IP. This is the gateway for IPv4 protocols and two name servers. What I'm going to do, I will save that file at the moment. And the next thing what I have to do, I have to apply the netplan. So the command to do it is netplan apply. I'm going to use debug option because that will display any errors, any problems potentially which may have been created here. So let me run. I don't have any, I don't see any errors here. So most likely it has been applied. So what I can try to do, I could check, do we have IP root? Now we have default root, and default root is going through the interface of the firewall. It will be 3 at this stage, and I'll try to ping. Okay, and the ping is working. Now, we could ask, how is it possible that ping is working when no rules have been created yet? Basically, OPNSense firewall by default, when it's installed, it's allow outbound traffic. So that's what happened here. We may be changing. We may be changing this later. So that's all. What I've done here, I've configured the LAN-facing interface of OPNSense as my as a default gateway on Ubuntu, and I added DNS server. So as a result, I will have access to any websites later. That's all what have been done. So we could just configure static IP, and that's another option which could be done, but it will work in the way as we have configured it here. So now it's ready to configure some rules. So on the firewall, our internet-facing wide area network facing interface is 10.0.104. So what I've done as well, I took my Kali Linux, which is connected to that network, and I've tried to run nmap against one interface, and we could see there's no port which would be open at the moment. So we'll be exposing those ports right now by sharing some internal services. So what I'm going to do, I'm going to publish the first service. So inside in the LAN network on this IP address on the port 80, I have default Nginx website. So what I'm going to do, I'm going to create a port forward. So basically, if somebody will go to my wide area network IP address to port 80, I'm going to forward him to the internal web server. And this web server will be published on the firewall. So the way how I'm going to do it, I go to the firewall option here. I select NAT, and I'm going to select, in this case, port forward. So I'm going to create a new NAT rule. So this interface 1, TCP version 4, protocol TCP. And now what the destination is going to be. So basically, when somebody is going to go to my firewall wide area network interface, I'm selecting the destination is wide area network address. So if somebody will go to this address, and when he will go to port HTTP, so port 80, I'm going to redirect him to a single host or network. So in this case, it's going to be 172.16.104 because this is my internal web server. So let me type it here. 104, and the target port is HTTP as well. I may decide to log those options, so it will be easier for me later on to review what is happening. There's an interesting function here in OPNSense Firewall. It may create a firewall rule for us automatically. I don't want it. I'm going to create a firewall rule myself manually. So I select here option none. However, if we would create add associated filter rule, the firewall would create that rule for us. I'm selecting none because I want to show you how to create those rules. So I hit save, and there's apply changes. So we can see this new rule has been created here. So this is my second rule. So if anybody, so any address, any port, go to my one address to port 80, it will be redirected to inside. So this is 172.16.104, which is my internal the web server. He will be redirected to port 40. It is not working at the moment because there is no firewall rule. So what I have to do here on the rule option, I'm going to create a rule on the one interface. So I add new with various options here. So I'm going to select pass because I want to allow traffic. This is a rule which will be created on the one interface, again TCP version 4, and this is going to be TCP, this web service. This is where it's going to work. It will be any IP, so whoever is going to this, or what we could specify that is non-LAN. Yes, but it is perfectly fine at this stage if we select any source. Yeah. Now our destination. Destination is single host or network, and I'm going to put here that this is IP address of our web server. So if somebody is going to 172.16.104 and destination port range, I'm selecting this is going to be HTTP. So if somebody is going to this, the traffic is directed to this IP to port HTTP, it should pass. I'm going to log the packets. So I want to be able to see those options. And I can save and they apply changes. So at the moment I've created NAT rule for port forward, and I have created a corresponding firewall rule which will specify if something is going to this interface, it should be allowed to travel. So what I've just done on this diagram, we can see this is where the web server is. On port 80, I have the web service, and this has been published on the one interface of my OPNSense firewall. So if I would like to verify what I have just done, I want to get a Kali Linux which is connected to outside network and try to connect to one interface of the firewall. And what I would like to see is that a port is forwarded to the web server, and I should be able to see this on the Kali Linux. So let's check it. So let's verify configuration at the moment. Our one interface on the firewall is 10.0.104, and my Kali is connected to that network. So what I'm going to do with Nmap, I'm going to check if port 80 is open, and indeed it showed me port 80 is open. So potentially it is working there. So what I'm going to do, I start the web browser and try to connect, and bingo, we are connected to port 80. So it seems to be working. So there is one last verification what I want to do. On the Ubuntu server, where the web server is internally in our LAN, there are two web services. One is working on port 80 and one is working on port 10,000. So what I would like to do, I would like to be able to connect to my firewall to the one interface, and I would like to be redirected to internal web server which is working on port 10,000. However, what I want to do, I don't want here to go to port 10,000, I want to go to port 81. So let's do this configuration. So basically, what I'm going to do, I'm going to configure another rule here. So first, I'm going to NAT port forward. This is my internal IP. So I'm going to add another rule, just one word, which is worth to notice. Normally, in normal situation, I wouldn't be recreating entire rule. I could just mark it and I could clone that rule, and I would be able to do the modification. However, we want to do everything from scratch here manually. So we are working on one interface, IP version 4 TCP, and the destination. So if somebody from the internet is trying to connect to one address, and we are specifying different ports. So if somebody is trying to connect to port 81, which at the moment is not in use, he will be redirected internally to 172.16.104, and the target port redirection will be 10,000. So this is where we are going to send him, and I want to log this information. So I would like to be able to review this in the log. And in this case, I will say, okay, add associated filter rule. So I will allow Firewall to create a rule for me this time. Okay. So I just apply the change. Now there's a different icon here at the moment. I have the configuration 1 TCP, one address port 81, and it's redirected here to port 10,000. If I look on firewall rules at the moment, there will be another rule on 1, and we could see it's exactly the same, but this is associated rule, and it has been created via NAT. So when I created NAT, it created a firewall rule here. So let's see if this is working. So what I'm going to do, I'm going to get that IP on a different tab. I just specify here port 81, because that's where I want to connect myself. Hey, something happened here. Yes, I've connected. It's a different port. See, the wording is slightly different here. If you see this page, the Nginx web server, and here is, if you see this page, this means that Nginx web server is working. So they are two different folders exposed. So we could see we have created two port forward rules. One, when somebody go to external port 80 on the one address, he's redirected internally here to port 80 as well. And this one is with port change. So if somebody go to the one address, port 81 from outside, he's redirected to this web server to port 10,000. This one created associated rules. So please have a look. We have to have rules here, and the rule is always from source to destination. Firewall first process NAT, and then process firewall rule. So by the time when firewall will look in the packet, the destination will be translated. So this is why we created rules this way. So now we have a lab which is ready, and we can try to play with some other configuration options. So let's verify what we have done as well using Nmap scan. Only at this stage I'm not scanning any specific ports. I just scan default set of ports. So I can just run Nmap here, and what has happened? I got that port 80 and 81 is open. In the meantime, please note here on the firewall there is plenty of blocking rules being triggered because we have scanned it. Yeah, so we could see that firewall is actually working because it's blocking number of things. So this is very good lab. We could try how the things works here. See, okay, port 80, 81 is open. It did identify service incorrectly because on port 81 there should be something else. But if we would run nmap differently with actual verification what's there, it most likely would detect its engines working there.